I'm going to talk about the movement of molecules towards a cell. First of all, I'll talk about passive transport, which includes diffusion, osmosis, facilitated diffusion. First of all, diffusion is the movement from high concentration to the low concentration. This is a picture of diffusion. As you can see, the movement is from high concentration to low concentration. So eventually, both sides become equal. There are three. You can classify all solutions in three based on the concentration. First, isotonic, second, hypertonic, and third, hypotonic. This is a brief picture of all three solutions. As you can see, the isotonic solution has same amount of water and solute. Hypertonic has more solute and less water. Hypotonic has less solute and more water. First of all, isotonic solution has equal solute and equal water. This is how it looks like, and a cell has no problem in this water. It doesn't shrivel, nor it doesn't burst. Secondly, hypertonic solution, it has more solute and less water. This is how it looks like. As you can see, it has more solute than the isotonic solution, and the problem is that the cell loses water, and so it shrivels and eventually dies. Thirdly, there is the hypotonic solution. It has less solute and more water. As you can see, it has less solute than the isotonic solution and definitely less solute than the hypertonic solution. The problem is that the cell gains water and so it bursts, and this eventually leads to death of the cell. Osmosis is the process of diffusion of water. As I told before, diffusion is the movement of high concentration to low concentration. Osmosis is the same, except that osmosis is the term that refers specifically to water. Facilitated diffusion is the diffusion through protein channels. As you can see, that these protein channels help the diffusion, and so the molecules move from the high concentration to the low concentration through these protein channels. Now I'll talk about active transport. Active transport requires energy, while the passive transport, which I talked before, doesn't require any energy. The energy required in active transport is called ATP, and this is because cells may need to move molecules against concentration gradient. Sodium potassium pump. This is the first active transport, and it's also called as protein pump. It requires ATP. This protein pump in the picture is here to move the molecules that are against the concentration gradient. And endocytosis includes phagocytosis and pinocytosis. What it does is that it moves large molecules into a cell. Vesicles and vacuoles have a role in this process. First of all, phagocytosis, also known as cellular eating, fuses with lysosomes from digestion. Pinocytosis is cellular drinking, but it has non-specific process. Last of all, exocytosis, it releases substances. It's the opposite of endocytosis. It's similar to endocytosis, but instead of pushing the large molecules into the cell, it pushes it out. In other words, it releases the large molecules. So you can say that it's opposite from endocytosis. Thank you for listening.